Oh, this is ME4111. Apologies for the delay in getting further solutions up. What I've opted to do was to scan in solutions I worked out and talk over those rather than trying to type out the equations, because it was just taking an age to get through those using an equation editor. So hopefully this version of stuff will work. It's been interesting trying to get this stuff together. Okay, so question 8. We have a cutting tool and a lathe, which has a force. So again, given the kilonewtons here, 6I hat minus 4J hat minus 7K hat. Again, if you look at the notation here, very often in textbooks, you'll see this kind of a bold writing for the vector form. And that's quite typical. So the vectors are and bold, and write them either underlined or with an arrow over them. And the usual thing is to write an arrow over them. And unit vectors are given a hat. So we refer to them as I hat, J hat, and K hat to indicate that you're indicating vector terms with that. Right, so we have that broken down into 3 components. And if you look at the previous questions, a lot of them were asking us to do that. So in this question, it's done for the Z and the Y axes. Okay, so we want to know what kind of turning effect this causes about the Z axis and also about the Y axis. Okay, and we're given here the answers in Newton meters. Okay, so the distance here we're given is 30 millimeters. And if you take 30 millimeters and take a product with kilonewtons, you'll end up with a Newton meter range. So what we do is we bring the distance into meters and we bring the force into newtons, because our results then the moment would be in terms of Newton meters. Right. So talk us through it first. And the first thing that we do is we just work out, okay, we need MZ and we need MY. And what I'm going to do is I'm actually going to use the vector cross product here, and I'm going to work out the I hat, J hat, and K hat terms for the moment. And again, I need to do that. Another way you can do this, which we've done in class, where you look in from the respective axes. But in this example, I'm just going to do it in terms of the I hat, J hat, and K hat using the vector cross product approach. So I need to define the vector R and the vector F. The vector F we have already, that's 6 and K hat. And that means I need to now work out what the vector R is. So the displacement vector here is from this point, the center where we're taking the moment. So the central axis, we'll take that as our point. And all the axes intersect about here. And by choosing this point, by working at the moment at this point, I'll work at the moment about the x-axis, the y-axis, and the z-axis. I want the space to sum the action of the force, and where the force is acting is at this point. It might be easier to go back to this one actually. Is at this point here. So it is from this point up to that point there. That's the displacement that I want. So what I'm going to do is work out if I'm standing at this location. So again, if we go back to the larger one, if this distance here is 30 millimeters, I'd go 30 cos 40 would bring me out along the x-axis. So that's 30 cos 40 I hat. I don't go anywhere on the y-axis, so 0 j hat. I got to go up in the z-axis, so plus 30 sine 40 k hat. Okay, and if I look at my figure here, I got 3 cos 40 I hat. So again, that's plus in the plus direction, it's going out. I have 0 j hat and 0.03 sine 40 k hat. And again, that is plus because it's point. Okay, so that gives me the displacement vector, and I already have the force. So now it is the vector cross product of R cross F. And again, that sequence is important. It's the displacement vector first and the force. So it's I hat, J hat, K hat. I have my displacement vector, so 0.023 I hat 0 j hat and 0.019 k hat. So that's the displacement vector. And then I have the force F. And again, I've brought this into newtons. And I simply evaluate out that. And I get an I hat term, a j hat term, and a k hat term. So if I multiply those out, I end up with plus 76 I hat, k hat Newton meters. And the question asked me, well, what's the moment about the y-axis and the z-axis? Well, the y-axis is simply this term here. It's the j hat 1. And the k hat 1 is the z1 there. That I'll just, so that's our z-axis. I have that also. That's there as the 76. Okay. Thank you for listening, and I hope you found that useful. Again, your feedback will be appreciated if you find this format works, if it's clear enough on the slides for you to see the workings. Certainly from my end, it's much faster to produce these than to. All right, thank you for listening.